guys are going to kind of go back to using your dissociation equations to do this type of concentration stuff. So you may have to calculate the concentration of ions in a solution. Once you have your dissociation equation, so remember what thing is dissociated? What do I start with if I have to dissociate something? What type of compounds dissociate when they're put in water? Yellow question. Really?
Solute.
Okay, that's a generally solutes, but what type of solute compound will dissociate when it's put in water? Ionic. Okay, so if you have an ionic compound, that looks terribly not like the word ionic. Okay, ionic. Ionic compounds will dissociate. What ionizes? Thank you. Yes. Do you guys not remember this, or do you feel like you're just tired? I feel like I said it like 100 times. Okay, write it on the top of your sheet. Ionic compounds dissociate. Acidic compounds, they ionize. And molecular compounds, they just dissolve or not dissolve. They can't break up into ions and they can't make ions, okay? So we just say either they're dissolved aqueous or not dissolved solid. So ionic compounds dissociate, S is ionized, molecular dissolve or not dissolve. So you need to be able to know these. Very, very important. Okay, very important that you understand the differences. Okay, so once you have your dissociation equation, which you make from an ionic compound, you can calculate the concentration of ions in solution using the mole ratio. So how we do this is we go wanted over given. Okay, that's the mole ratio. And this is going to be used throughout the rest of the course, this type of a molar ratio. I'll explain as we go. So anions are negative ions, as we should be able to recall. And cations are our positive ions. So as you're going through, make sure that you're just being clear. Okay, so for example, we have this calculate the ion concentrations of 0.05 mole per liter solution of KCl. So KCl, what type of compound is that? Ionic. So that means we have to write out its dissociation equation first. So this is a more straightforward one. So first we started as solid, just being like before we put it into water, because the dissociation equation represents when we put it into water. Will it become aqueous? Like, will they break apart? You can check your solubility charts to know. Yeah, it's aqueous. So we can definitely break apart our potassium ions, so write it as an ion, and chlorine ions. Now the question is asking us, how much concentration do I have of these ions separately? So like how much concentration do I have K, and how much concentration do I have of Cl? So it's like taking an apple and then breaking it apart. Oh no, like let me use an orange. Okay, so it's like taking an orange and you peel it. So it's like you start with the orange together and then you break it up into like the inner part of the orange and the peels. So it's like how much concentration of inside do you have and how much peel do you have? So, but you need to know what you have to start with. So what we know, oh, and you have to balance it. So it's all 1 to 1 to 1, okay? Balancing it is super important, okay? So then, this is like foundation for the next unit. So if you kind of are, make sure you take the time to follow along this part because it's super helpful for the next part. So the way that I do this is I write underneath of each thing the information I know about it. So underneath KCl, I'm going to write 0.05 mole per liter. Okay? That's what I know about it. And under K, let me see here. No. Okay, so under K, I would put like, this is what I'm trying to find out. The C is our question mark, and C is question mark, okay? Now, when you're trying to find out something, you say that it's the wanted. When you are given information, you call that the given. So in this formula, write a G over KCl, or you can actually write the whole word, given. And then the K is wanted, and the Cl is also wanted. So now for each of them, we have to set up the molar ratio, which is what? What was it? Did it say? Given over wanted or wanted over given? Okay, wanted over given. So now what you do is you take our mole per liter and you multiply it by wanted over given. Okay, so it's like the molar ratio, here's the wanted over given. They're both 1 and 1 though. Okay? So it's like the general formula is take the given concentration and you multiply it by wanted over given, and this is your mole ratio. So you take the given concentration, multiply it by your mole ratio, which is wanted over given. Now, as you can probably clearly see, the concentrations will be the same because it's all 1 to 1. So then we can conclude that our concentration of our K is 0.050 moles per liter. And if we did the same thing to our Cl, we take our given concentration, we multiply it by 1 over 1, because it's wanted over given, and we get our concentration of our Cl. So when it asks you a question like calculate all the ion concentrations, you still have to do each calculation separately, okay? Or just like show them each separately. All right, so let's do a little bit more complex one now. Maybe I should start